Hello, ladies and gentlemen. Welcome to Math 30-1, Chapter 7, Section 2, Solving Types of Trig Equations Algebraically Notes. Now, as you recall, last lesson we used the graphing calculator to solve trig equations. Sometimes it's the only way. For example, a mixture of trig functions and polynomials like this example here. 3 cos of x minus 2 sine squared of x equals minus x squared plus 6x minus 10. For 0 is less than or equal to x is less than 2 pi. And no, I'm not going to try solving that. You guys can graph if you want. I'm not going to. What I want you to be able to do, though, is to look at this. Sorry, my apologies. For the rest of these equations, you should be able to solve for them algebraically, but you might have to be like that. But you have to be aware of tricks. So let's try this again. So a basic equation like cos of x is equal to root of 2 over 2 for 0 is less than or equal to x is less than or equal to 360. Now, what's the first thing I expect you to do? Graph it. I don't care. Graph the darn thing. It's not a suggestion. Graph it. So, grab your graphing calculator and graph it. Stop that, people are watching. Bloody micro squish. Let's try this again. So, cosine graph goes like that. And we're stopping just shy of 360, 180. So there we go. Now, root 2 over 2 is 45 degrees. So you should know root 2 over 2. Something like that. Yeah, not the best drawing. Try that again. Oh, what is your issue? Micro squish. 2 over 2 is roughly like... Last nerve, you're getting on it. Stop it. Be like that. Now, right off the bat, that's good. Now, the reason I want you to draw the graph is that there is a second answer over here. And I happen to know from bitter experience, this is 45 degrees from the beginning. This would be 45 degrees from the end, which is 315 degrees. So you draw the graph and you go, oh, there's two solutions here. As I said, y1 is cos of x, y2 is square root of 2 over 2, not the decimal approximation. Right? No. That's what you need to be able to do. Draw the graph and realize what's going on. Now, if you do this algebraically, cos of x is square root of 2 over 2. Angle x is cos to the minus 1, square root of 2 over 2. Angle x is 45 degrees. That's what you do on your calculator. Now here, you have to draw the graph and realize that there's a second answer, 315 degrees. Now this is trick number 1. Multiple answers. Almost always, not always, but almost always, there's multiple answers. All right? Now, I want you to note symmetry. Draw a line down the middle. You notice how this is a reflection across the line of x equals 180 degrees. So if you get one answer at 45 degrees, you get the other answer, 45 degrees in, the other answer is 45 degrees from the end. Note that, please. So note the symmetry and note the trick. So far, so good? Now, next question, next example, basic equation. 15 sine of x plus 13 is equals 0 for 0 is less than or equal to x less than 2 pi. Less than 2 pi does not include 2 pi. So 15 sine of x plus 13 equals 0. 15 sine of x equals minus 13. Sine of x is minus 13 over 15. Now that is not a nice angle, so you're going to have to plug that in. Inverse sine, minus 13 over 15. That's 1.05 radians. Now, a few things here. I really hope you've drawn your graph. Now, do we draw this graph? No. We draw this one. Simplify it a little bit. That way we know what's going on. Okay. So there's a sine of x. Two pi. Now, minus 13 over 15 is down here. And note once again, there's two answers. Okay. So, here, you got that? All right. So I was going to say approximately minus pi over 3 radians. Now, two things here. Minus 1.05 radians is pi over 3, minus 1.05 is minus pi over 3. That's one of those numbers you're going to have to learn to recognize on your calculator. Pi over 2, pi over 3, pi over 4, those numbers pop up a lot. You have to know what they are as decimal approximations. Now, more importantly here, where the heck is minus 1.05 radians? It's over here. So what's Mr. Calculator done? It's given you the nearest answer. But this leads right to trick number 2, domains. The calculator is giving you an answer outside of your domain. Now, you gotta go, oh crap. I mean, realize, what's the period of a sine wave? Plus 2 pi. So the answer here, you add 2 pi to it, minus pi over 3 plus 6 pi over 3, 5 pi over 3. So this answer is 5 pi over 3. Okay? So far, so good. Now remember, trick number 1, multiple answers. Yes, there's a second answer right here. Where the heck are we? Well, there's a couple of ways to do it. I'd like you to note the symmetry. Down the middle here. Now, what's halfway between pi and 2 pi? 3 pi over 2. So this answer here is 2 pi minus pi over 3. Going backwards. This answer will be pi plus pi over 3, or 4 pi over 3 will be our second answer, or should be. All right. So far, so good. Well, I want you to see that. Now, there are other ways to do it, but that I think is the easiest. So far, so goodish? Well, I hope so. Should we do one more example? No, I'm going to pause the recording here because there's rather a lot of these. So I'm going to pause it here. I want you to look at these. Then we're going to go on and do some more trick or solving these algebraically and graphing. All right? Any questions, shoot me an email. Otherwise, good luck.